What to crowd? Right. Hello, everyone. Welcome to SIG scheduling meeting. This session is recorded as usual, so please behave well. Right, let's get started. I'm gonna share the screen. Okay. So today's only topic is about node readiness gates, as we already discussed. Oops. Yep, this one.
Can I share some slides to maybe give a...
Okay, okay, of course.
All right, thanks for the discussion and the feedbacks at the talk. I think that I already presented the idea, like we're kind of in the same page. I just wanted to give a quick overview on the definite problems that we are looking to solve and some of the continuing discussions from the doc on the design aspects. So I'd like to use this time to maybe get a better understanding and a clarity. So essentially the problem statement is that the node signal on when it is ready is not enough today. It doesn't sufficiently capture the actual workload readiness in this time, when readiness would mean many different things. Like it would need that like a security agent need to be established on the node, or some infrastructure layers like storage arrays that need to be provisioned, the drivers installed, and the volumes need to be realized before the workloads can be scheduled onto the node. And specifically for the case of networking, it is it is more important, because now pod network ready would mean that the CNI installation is correct, is complete, and then the DNS is ready, or the service mesh is ready if that service needs like a service identity that need to be provisioned before, that needs to be created before the pods could be assigned on the node. So these are the critical use cases. I think that another important use case that kind of like we see at Google internally as well is that when GPU nodes, GPU drivers are installed, like it could be like a driver mismatch, or it's simply just like assigning a daemon set onto the node doesn't really bring the node into a ready condition where it would give that idea to dependencies like scheduler or cluster autoscaler that things are ready and I can assign workloads on top of it. This causes often cascading failures on top, like node GPU not installed, but then like you would want to layer on top of dependency on it, like a maybe like a pod cache or other services that you want to establish on top. So this would take, if everything looks good, like order of minutes. Definitely that's not like a good wait time. Like it's easy for pods to assign on the node and things can go wrong. Taint works, but it has that limitations where it is not expressive enough and it doesn't bring out the failure conditions correctly, or it's basically like not very sufficiently, in my opinion, sufficiently like handling the bootstrapping conditions. So that's where the idea like about like having that as first class interest in Kubernetes or node could help this case. That's why we came up with this idea about like node readiness gates. The goal is to have extensible readiness that the admins or intra admins could declare that the node should achieve before um, able to be actually ready, like workload ready to be able to get um, pods assigned to them. Now there are of course like more things to consider here. Like few things we discussed was about like layered readiness. Should it be like a one binary, yes I am workload ready now, or it's more kind of like I am network ready, storage ready, like similar to like Linux equivalent of run levels on the node. That's one like discussion that we had. And another one is like having this um, expressed more as requirements on the pod itself. Pod says, okay, I want to see these things at the node before I can be assigned on the node. So there are like different um, kind of like angles to this, but we want to establish the bare minimum first, having that core API on how node could declare this is what ready to me, and like giving it for the components, option for the components. And the second one is like standardizing.
Excuse me,
Yeah.
I have a question.
Yes, please.
So the question is whether the node readiness is defined for all nodes and for all pods in the same way, or do we want to define different readiness for different nodes, different kinds of nodes,
Mhm.
and for different kind of pods or workloads that are need to be scheduled there?
Got it. That's a great question. When you say like different types of nodes, I'm imagining something like a um, GPU node, a non-GPU node. You want it to be more um, implicitly understood. Is that what your question is?
Mm-hmm.
Got
Yeah,
it.
that's
Yeah, I see that like realistically, like how this is achieved today is that like a GPU node pool or like a node class in Carpenter or something could have that readiness gate, for example, GPU ready on that GPU node pool and not on the other node pools. That's how I see this could be realized. Implicitly specifying I would get on that would not work for the user intent. User should be able to express what I want to block the workloads on. That's why it's, I think that like implicitly tainting or like implicitly like gating on certain assumptions on the node. Maybe like some optimizations we could see forward, but initially I think that like it should be user declaring that intent would be the good approach.
so. Let me just confirm one thing. So
Mhm.
you are saying that the definition of readiness may be different for different types of nodes. Is
Yeah.
that correct?
Yes. Mhm.
Okay. And now, so if we talk about readiness, do we mean that this is readiness for all kind of pods? Or do we think about a few different types of readiness depending on what kind of workload you want to run? And let's say, ignore a daemon set for now. Just
Mhm. Yeah.
so do you envision that there would be different workloads which needs different like level of readiness, or not really?
Yeah, I think that like that would have to come as a follow-up, not like in its current stage right now. Like we are looking only at blocking it for the general workloads, not for um, like different types of readiness. That's what I like mentioned about different levels of readiness, network ready or storage ready. Um, I think that like that could be additive, establishing like an infrastructure level readiness, and then workloads could have for example a security agent that infrastructure provider want to install on all of the node, could be like a base readiness, or like even network readiness could be in some cases be applicable for all of the nodes. So anything that's applicable for any pod that can be applied on this node need to wait for this. that's what I think that like I'm targeting with this gap. I agree that like different levels of readiness would be the North Star would be more preferable, because like we don't want to add latency to all the pods when it doesn't make sense for like some non-storage pod to wait. I mean, pods that doesn't provision any volumes to wait on a storage condition, of course. But I think that like having this in the pod spec, I think that like more like requirements or like prerequisites for the pod would probably like still need to think through and would need to be followed up, because we have other projects in Node and we want to make sure we address all the use cases and we align on the directions.
Okay, thanks.
Kensei, you have your hands up.
Oh yeah, so from when I first saw this proposal, I'm not sure. I don't understand why taints and toleration is not enough for this use case, because you can define different kinds of taints and you can define different kinds of toleration based on the pod's, nature, what pods needs. Like if pods are, uh, needing some GPU, then they can put several, corresponding correlations on it.
Yeah. So the idea is that like to standardize this, instead of like everyone bringing in their own custom controller, um, for fundamental critical like just talking from the device installation, I mean driver installation, or like network driver installation, or storage installation, right? This doesn't need to be managed with like individual taint controllers. What happens is many times is like, I mean, I think I could give a couple of examples. One over here is when a driver has like a race condition that the taint is not um, like removed, then it needs to explicitly needs user intervention. You need to restart the pod and make sure that like the taint removal happens again. This is from a particular I mean issue I could just like share after this, but one example, I mean, we are depending on the taint controllers are like handling all the removal cases correctly, and we would want to have the perfect implementation on like third-party controllers, and having it like realized in many third-party controllers, even for fundamental readiness, right? We want to avoid that, and having this expressed with conditions would make better visibility for node. It would bring out like what exactly is fault at the node. um, Taint, the problem with just having taints is that like it's binary, either it is present or it is not, and once it is removed, you don't have trace of like what happened at the node. It's hard to get that connect. That's another important aspect for node debugging. We have even seen cases at Google where like recently we had an OMG where like a taint was missed, and it was hard to root cause to like where exactly was the gap. And so I think that like better observability is important for node. I think that like having it connected in some way to the conditions, like having components express their state in node would be beneficial. And I think that that's where connecting that feedback from components or nodes is important. And another aspect I think is important is like having the controllers running in the node is a security wide like I would say like wide RBAC, because like taint is on the spec. We would be patching the spec from within the node, especially when it has like multiple dependencies. All the third-party controllers would need these permissions. However, status update is not the spec, but on the state is more on the observed state. That is like lower risk and lower RBAC scope for the controllers themselves. That's another important aspects um, that we need to consider on why having directly allowing it to update the spec is probably like not a great idea for us, especially for components expressing their readiness. One thing I think that fundamentally is I see is valuable is that semantic clarity. Taint doesn't say, of course, it has that categorical intent in it. It says like whether this, what about the node? I think that like Dominic also had commented on that uh, categorical nature. Readiness is more of a temporal nature. Like it needs to have that it's ready and then it stays on the node, right? That semantic is not, I think that is not correctly expressed as with taints. Hope I get my thoughts across, please.
Okay.
Okay, so is also a part of the problem that the changes in API server takes time and it's hard to keep them in sync with the real node status. Is this what you also mentioned, or not exactly?
I mean, I think if I get you correctly, API server not having the node status. Do you mean the latency of when it is available? I'm not sure. Like,
Yeah, is it the latency problem as well?
I think that problem won't go away even now, because like even condition has to be updated on the API for it to be realized at the scheduler. So that I think that like would stay, but one better realization is that like having, for example, if you do it in a node controller, like the status is synced with every heartbeat every 40 seconds. So a missed taint would just be like a delay of 40 seconds until the next update. We don't need to depend on the taint controller's realization of this, whether it handles the fail cases and whether it needs user intention to restart the pods. Those goes away. Yeah, but latency in itself um, isn't helped by node readiness gates, because we still need to patch the condition on the node.
Mm-hmm.
However, I think I added this at the comment at the original issue. I think like we had some discussion. I don't know if Kensei or someone else from SIG scheduling. Having an update on the spec would mean that admission controllers for like a core component like node would all need to go through. That would add a latency difference if there has like some node modifications or like other mechanisms at the API server. But state is less sub resource and is less likely to have admission controllers or other things at the API server. So that would help to move this faster or lighter than a spec update. Just to add a data point. I mean,
Right.
I'm not saying ubiquitously, depends on cluster, of course.
Okay.
So the point two, right? Poor visibility. Like, can you elaborate it? Like, I mean, and how would it solved by node readiness gate?
Yeah.
Like, I mean, it sounds like taints as well. We can have multiple taints if we want. Like that kind of, that could help how, like which taint is not uh, removed yet, or like, if you want, you can even put a custom condition on node so that everyone can debug things more deeply, like when they are debugging.
I think what I am looking at is not what I'm hearing is that like why can't we have multiple taints express different states? For example, degraded or I don't know, like it's upgrade failed, things like that. What I'm um, like suggesting here is like conditions are like richer status by design. They express reason and message. They also have the update time, so you could track, maybe like build like a dashboard based on nodes conditions to capture like the evolution or like the progress on the node, which is not possible with taint. Of course, like you can have different like the specific taints for different logical flow, but that would just cause like an explosion of taints, and it cannot be how do I say that, like generalized for a cluster admin.
Okay.
So one of the reasons I was asking about those different type of conditions, whether they are permanent or whether they are like temporal. So like here we have a timeout for them to go away, and some action, what happens if it's wrong. So I was trying to determine whether this should translate to scheduling taints or to something different. So I mentioned binding conditions, but also we could think about this. So in scheduling we have a few different phases, and binding is when we decide to run a workload, but there is also a permit gate. So some workloads may be scheduled, but they are not allowed yet to be bound. And those conditions which are temporal, so the ones that should go away after some time, does not necessarily need to block scheduling. So not necessarily they need taint semantic, but they may block the permission. So or we can call it admission. So we have a workload that is scheduled, but we don't let it go yet until all the nodes are ready. I don't know, the cluster scaled necessary nodes appeared, and so on. This is why I'm trying to think whether the conditions should translate to taints or to something more flexible.
In that point, I prefer to stick to taints and translations, especially like this timeout stuff as well. Like let's say it has timeout like 3 minutes. It looks like, for almost all pods, instead of waiting for 3 minutes, it's probably better to schedule them to another nodes, or even like triggers burst out scale to spin up a new node, which may take also time to be ready. But we don't know if those unready nodes are really gonna be.
But this is exactly my point. If you schedule something on nodes which need to be scaled up, needs to be provisioned. Cluster autoscaler or converter decides that some pods will go to the node which does not exist yet. When those nodes appear in the cluster, they will appear with those conditions that node is not ready. If we use taints for that, that means that the workload that was scheduled there needs to be rescheduled because the taint is blocking scheduling. And we will again start looking for a different node for it.
Okay, my another point here is that like let's say, okay, there's no enough nodes elsewhere, and cluster autoscaler triggered some scaling up. But while waiting for scaling up, some pods might be just finished, like deleted, right? And those deletion might create some additional like resources on the cluster. In that case, instead of just waiting cluster.scale to create a new node, probably we should just schedule the pods to there, right?
But I think it's orthogonal. It always can happen. I think waiting on permit does not mean that we cannot look for and reschedule.
Well,
But
currently
if
it does, right?
sorry,
Because currently it does, because if you let the pods waiting on permit like at the beginning of binding cycles, then those pods won't be rescheduled unless you explicitly deny those pods.
yeah, but this is like sure. But
I
this
think
is
it's simpler
how,
to,
for
yeah,
instance,
for
this
me
is how
it
Q works, right?
right.
So Q tries to find some placement. It decides that okay, let's go, and the magic happens. So the nodes that need to be turned out start appearing, and Q decides when to take a decision to look for a better placement. It's not like Cube scheduler deciding that
If
okay,
you say
there is
queue, it's a KQ. It's scheduler queue or it's our side project queue.
yeah. So Cube scheduler basically does not reschedule workload if it was
Yeah,
scheduled by Q by K.
by
Okay,
KQ, okay.
KQ, yeah.
Yeah, I mean, yeah, I think it's just simpler in the current model. Like currently what we are doing is just waiting for those taints to be removed, right? And then all of them are removed, then those can be a candidate for the pods. And what what you were saying, like what sounded to me is like uh, waiting those nodes to be ready at the wait on permit phase, right?
Yeah, well, nodes which wait on permit phase are those which are scheduled by custom plugins. So they will wait on permit. And they don't try to be rescheduled even if new free nodes appear, because it's some external controller, this plugin controls when to reschedule the workload. So it's not Kube
Yeah,
scheduler who decides on it.
why are we talking about external scheduler here?
No, the custom plugin and gang scheduling, which use permit.
Yeah, okay. So we are talking about waiting schedules, right? And you are saying that even some unready nodes, we may be able to park some pods at the wait on permit phase, isn't it?
Can you repeat the last sentence?
Maybe I misunderstood what you were saying at some point. Like, yeah. So what you were saying is that okay, nodes are unready, and but we expect those nodes to be ready at some point. So we can pre-schedule some pods on those nodes, but but we cannot run those pods until the nodes get actually ready. So we have to park those a pod at the beginning of the binding cycle, which is wait on permit. Isn't
Let's
that
say.
yeah? Isn't that it is what you're saying, right?
Yeah, more or less. So we don't have that. So it's hard to talk about something that we don't have. But I think it might be useful to distinguish things that should block scheduling, and scheduling should not consider those pods. And we have different kind of conditions which don't block scheduling, but should block.
May I
Wait,
have
so
a quick question? Sorry, I think like I lost you at the end of the sentence. I didn't understand the benefit of scheduling a pod in that case. If we know that, if scheduler can decide and know that the node is not ready, what is the advantage of scheduling but leaving it left to be bound?
Mm-hmm.
yeah, that's my point.
Yeah, so I think the problem is that we talk about scheduling like we understand today, and scheduling how we could understand like more in a workload world, when workload scheduling, and currently what Q does, it schedules workload, but it schedules workload outside of Kube scheduler. And we can call it scheduling, or don't have to call it scheduling, but workload is scheduled somewhere logically. Yes, it is not scheduled through Kube scheduler yet, because I don't know, several things have to happen before Q admits a workload to be scheduled on Kube scheduler. So I'm talking about scheduling as something that is more abstract thing that may happen in Q, not necessarily that happens in Kube scheduler.
So if I understand you correctly, Kube scheduler decides that, okay, I have handled this pod. It's up to Q or another entity to move them or place them onto the node. And by having binding conditions, we are basically giving rules for that entity to be able to make smart decisions. Is my understanding correct?
Yeah, the binding conditions may basically tell, for instance, Q that it cannot admit the workload yet because the nodes are not ready.
But okay, my point is why we have to proceed to binding phase in the first place. We can just reject those nodes at the filter phase. That's my, that's my point.
In the current scheduler, yes, it doesn't make sense.
I have a quick question.
So I'm not. Yeah.
Sorry, go ahead.
Go ahead. Sorry.
Oh no,
You can
I
go
was just
ahead.
going to ask, wouldn't it make it better to filter down the nodes that are not ready or not in a position to recover? Imagine that like a driver installation failed. Now assigning a pod, I mean, Kubernetes scheduler basically like handled the pod onto a node would mean that it sorted that out, right? Would that make it less correct than scoop Kube scheduler filtering down the nodes that are not in the right shape earlier? I'm not sure like about the scheduling correctness on doing it earlier or later, but it feels to be that like just like how pods are filtered down to make it eligible for scheduling later, nodes having it filtered down earlier seems to be more straightforward thinking to me. Not sure if I clarified my.
Yeah. So if we just think about kube scheduler, how it works now, there should be taints which block scheduling as an effect of the conditions and not ready. I wonder if Q should consider those taints as well when scheduling workload logically. Because Q,
But basically, basically Q also, at least current Q, also like filters out those painted nodes, right? When
yes,
calculating some topology of scheduling or something. Yeah.
yes, they would reject. They would understand those taints
Yeah.
as well.
Yeah. Right. So yeah, like I'm not sure when it happens. Like when when would we when do we want to schedule pods on tainted nodes, but park them on the right on permit phase? Is there any use case for that?
Mm,
Because those taints, like those nodes are tainted, right? And we are not sure when those taints are removed. Maybe forever. They may not be removed forever.
so the
In
ones
worst
which are
case.
temporal, the ones that are temporal, we know when they will become removed because they are timeouts.
What happens if we reach timeout?
There,
Because
as far as I understand, there is a action what happens if the timeouts is reached.
because when like timeout reached means node is not ready anyway, right?
Yeah, but I understand that this is error condition that
Okay.
Yeah.
node
If
provisioning
it's
simply failed.
if it's error condition, then we should not schedule pods onto those nodes, right?
Yeah, on error conditions, yes, of course.
So reaching timeout means the node is like not safe place, like not appropriate place anyway, right? Like I don't
Mm.
understand why timeout is coming here. Like if okay, let's say something happens, timeout reached. In that case, because something happened, the node is not like something goes wrong with the node, and that's the reason the taint is not removed yet. But because of that something that happened, like maybe node doesn't have enough like driver or enough something, right? So we should not schedule like any pause on them.
Yeah, I think the timeouts are not meant for us for scheduling. They are meant to control the turn up of a node and those phases. This is how I understand it, but AJ, you can confirm.
Yeah, in my mind, timeout basically would have to give two ideas. Like in the case of assume that like a driver version mismatch, and what's on the node doesn't work. So either it needs node maintenance, and so it shouldn't have pod scheduled on it. So treating it as taint would be fine because like um, workloads doesn't need to be laid on it, and it shouldn't delay the progress of the work itself. Now again, like if it is not something critical, maybe like an observability agent or something that the admin seems like, okay, like I need to be aware of it, so I'll be able to do something about it. In that case, the failure action could be like it could just be adding a warning or something that to signal um, the admin, so that like the workloads are not paused, but the admin would be able to do recovery action. These are these how I see it. Yeah, one blocking schedule, the admin intended.
Once, okay, so once timeout reached and failure action is, what's that? Warning mode or something, then we can still schedule some parts on them. Am I right?
If the failure action is taint, that means that user intentionally doesn't want to have scheduling because they see this is a blocking condition.
Okay.
Right.
Well, okay, so there are three conditions: taint, node, and two conditions: taint and bypass with warning.
So my question is, who is tracking those timeouts and who is a consumer of that information?
Right. So who is tracking the
And
timeouts? I can answer that. In my thinking, I think that it should be the individual kubelet in itself, just like how it is tracking the memory pressure or disk pressure condition purely for scalability reason. Node lifecycle controller or anything associated as a node tracking the timeout would not work for scalability. Just like how the current model is, when a timeout expired, when there is like a event happening, then kubelet could update like as a condition on the node, which node lifecycle controller can respond with like failure action. That's how I see it. So that like it would be like scalable first, and it also would be um, following the same responsibility model what I see. And like timeout, the initial node readiness gate was initialized by the kubelet, by the node, and it tracks the timeout to be more aligning with it.
So what I meant is, if we have information that there is a timeout, then we could assume in scheduling that in some time the pod will become ready. So for instance, we can schedule there something and assume that after this time the pod will be ready for binding. So this is how I wanted to use this information.
so my point is that what if until like those timeouts, like until like the pods are waiting for timeout to be reached, right? So that the pods can actually go there. But there could be some like cluster events that might make those pods schedulable for another fully ready pod, right? Sorry, fully ready node, right?
Yes, sure.
Yeah.
They could be.
Why do we have to consider those timeout on the scheduling?
I'm not saying we have to, but
mhm.
I mean we could.
Yeah, we could. Definitely we could.
And probably not in case of just pod scheduling, but in case of workload scheduling. So again, I'm thinking about something which we don't have yet, so that's why it's hard to have a common understanding what it may be useful for. So we don't have to like discuss it now until we have some clarity.
Yeah.
Okay. Do you see that um, would starting here in its current shape, we will be able to still like meet you at, I mean, I'm failing to see the binding conditions yet. Would starting off as blocking scheduling and then moving to schedule but then not bind, I think that migration is still um, okay to me. That do, what's your thought on that?
So I think it's important how we are meant to consume those conditions.
Mm.
And there are a few options. One of the option is to convert it somehow implicitly to taints, and they will block scheduling.
Mm-hmm.
Another option is to convert them into something that blocks something else. So blocks, I don't know, binding blocks, permit, but we don't have a use case yet. So I think it should be okay to, for now, to translate them to taints
Mm-hmm.
logically.
Mm-hmm.
But I think what is important to figure out, like what would be the logic of this conversion,
Right.
based on what condition, who, yeah.
Yeah, I think that like we previously discussed option A. I'm not like since we are leaning towards option B, just translating it to times. I want to discuss that. Um, what I am thinking is that like having uh, a node controller or a dedicated controller. If this, I mean, I think that node controller makes sense because it already um, informs. It has an informer on the node changes, and it already handles node conditions. If there is, it would get a node update, and if it realizes that like the condition updates are not enough to meet the nodes, meet the readiness gates, it would apply a single reserved taint. In my first phase, I think that's how it would make sense. This node readiness gate Kubernetes.io node readiness gate pending um, would be present, and every subsequent like direct condition update from the imagine a component posted ready, and this would fulfill um, the readiness requirements. This would land in API server, and eventually it will get a node controller. It would realize, okay, now all the conditions are satisfied, I can remove this taint. So it would remove the taint, would make this not eligible for scheduling. This is how this can be achieved. Of course, like thinking further into different levels, mapping granular um, taints for one for each condition, one for each readiness gate is optional. I'm not inclined to that idea, mostly because it would create unmanageable number of taints, and it would um, have multiplicative effect across the cluster. Having thousands of nodes would mean that we are increasing the number of updates or the like floating pieces, large large magnitude. I think just having a single reserve retained and following whether all the readiness gates on the node are satisfied with the conditions, and node controller just managing the singular taint would be the first step I would see would work. This would be similar to any taint management controller, just that it's inherent to Kubernetes. Um, in a way, we can realize that. I also want to add another thing. I think daemon sets could be included. Just having a precedence daemon set controller, like adds default tolerations today. It would be this default toleration additionally. The reason why I'm thinking this way is because like storage plugins are installed like as daemon sets, and a new node that's added wouldn't mean that the deployments have to be modified and managed only for those separate set of nodes that came up new, right? Then now you would have versioned daemon sets, versioned plugins maintained within the cluster, one for the new nodes, one for the old nodes, and rolling back all of that would make it complex. For that backward compatibility, I think that like daemon sets could be excluded um, from this taint, singular taint, but I think that I'm open to discuss that and why it should not be further on this. I think Kenzie had a point on that.
You mean all the demo set pods are implicitly get the toleration for the taint?
Yeah, for the toleration for the taint readiness gate pending, Kubernetes IO readiness gate pending. I think this is the same
But yeah,
behavior today.
what if they don't want to tolate? Like for example, okay, I can say for example, like log agent, they probably want to schedule log agent pod. Agent are often like daemon set, but probably they want to know, like want to wait for node to be ready, right?
Mm-hmm. I think that would be like we are looking at sequencing from within. Like what if like we want to make sure that this ordering is guaranteed? I think that would have to come after, like imagining this use case, right? I just like mentioned pod expressing the readiness required. Something like this, a workload can specify I need to meet this readiness would mean that okay, I have like a log agent that needs to have host network already established. Then it can have that. Having granular readiness condition is when all of these use cases could be satisfied.
Okay, so for this one as well, like why do we have to get this one? I mean, okay, because we already have relations, which is like, you know, they are already there, like very similar, right? Tolerations, sorry, yeah, tolerations are like allowing pods to be go there, and node readiness requirements are also similar, right?
I don't see they are similar because like here node readiness requirements are positive affirmations on what I
Okay.
need before to node.
Mhm,
This is like a flip of that. I think it would be hard to achieve this in tolerations unless
mhm, mhm.
the pod can specify everything that can be possible on the node and then layer it. Yeah.
Yeah, you're right.
But again, I'm leaving this out of scope on this one. So I think I want to see this as like a feasible um, next gap. So that's what I discuss here. The reason why this is out of scope on this one is because like um, again like DRA has something related to like conditions that it needs to mandate. So I think that like to keep the complexity simpler, I'm just like targeting on the base infra readiness simply. Yeah. But yeah, I just want to circle this idea because I think that like this is also like a scheduling requirement. This
Yeah.
cannot be
So
achieved with Paint. Yeah, just want us to.
okay. So regarding like, for example, some network related requirement, node readiness requirement. So let's say, okay, here you have like network proxy ready, right?
Mhm.
And do all ports have to get this condition,
No,
get this requirement?
no, only those that has, for example, in the case of Istio, only those that needs to have the sidecar injected, they need to have that. Is different from CNI ready, which is basically needed for all the pod network to be ready.
But like node readiness condition would contain very fundamental one as well, right? Some network, very fundamental layer of networking establishment stuff.
I think that like it
Then all the ports have to declare, okay, we have to get network establishment, so we have to get this in node readiness requirements.
I think that to answer your question, it's again like use case specific. Definitely, like not all the workloads would want to have that sidecar injected, basically like creating that service identity is not a need, I would think. But I mean, I would need to circle this with SIG network further on, like what is fundamental network readiness and what is like not. But again, like I'm leaving this because it's still in the not included in this script. It still need further definition on how this like layered readiness should be defined for the workload. But to answer your question, I don't know the use cases on what nodes need workload readiness. I would think that like not all of the, my primary goal is that not all of the workloads that are assigned on a GPU node need a GPU. They may just have, for example, like if CPU resources, GPU like nodes are just available, they can be utilized for other parts. So in those kind of cases, like this requirement layering could help. But again, like this would need further discussion, and I think that I'm happy to discuss this further with networking on other use cases and circle back with scheduling on further on a follow-up. Okay.
Yeah.
Yeah. So I think I have an impression that we simply need to implement some graph of dependencies, and that's basically all. So the nodes are the yeah, the conditions defined what you need to be able to move forward, and the what we already designing is declaring what is already there on a node.
Mm-hmm. Okay. So what I'm hearing is like scoping this for the fundamental infrastructure readiness as a use case is clearly at the cap. Is that what I am? Is my understanding correct of your statement?
So I tried to say that we seem to implement a turn-up graph. So the graph which defines which pods depends on which other pods and what is the order of the like starting. I don't know.
Oh yeah, got it. You're talking for the workload, basing the readiness on another workloads.
Even daemon sets. So
yeah,
what I'm looking at, you are like defining what conditions have to be met, right?
mm-hmm.
For this daemon to be started.
Yeah, that dependency graph. Yeah.
Mm-hmm. Yeah. Okay, I think that we can probably continue in the doc.
Yeah.
Okay.
The time is come.
All right.
Yeah. Does anyone want to say something before we wrap up? Right, cool. So thanks today for everyone. I'm gonna stop the recording.